Okay, page 205. Today, we're getting mad. Don't get glad, get mad. Wait, that's not how the commercial goes.
What commercial?
You never heard that commercial? For the Glad garbage bags? They say, don't get mad, because someone's like trying to stuff the garbage bag full of the really, like really full stuff, and then it breaks and stuff.
Mm-hmm.
You seen that? And then they say, don't get mad, get glad.
I've never
Because
seen
glad
that.
is the name of the garbage bag.
I think you're making that up.
No, I am 100%
I'm
not
gonna be
making
honest,
that
like,
up. Have you
I'm-
seen it? Oh, okay.
I'm
wow,
almost
you know.
positive that
This
you're
is.
I thought you were talking about the strength of way, whatever it is.
Mm-mm.
Why do you have to justify your
No, this is important part of your education here.
Okay.
watching ads?
Definitely.
That's so old. You think we'd see that?
Oh, hey, can you turn the volume up?
Cute commercial.
Addie.
Okay.
Welcome to Glad TV. Thanks, Skylar. Let's go to last night's highlights.
Hey, look, times have changed. Frank's haircut is still the
You
same.
know, my brother was in a commercial either.
There's Mom and Dad cleaning up. And there's the meatloaf. Yuck. Look what sometimes happens with the ordinary bag. It flips. Oh, bingo. Falls in. Mom wasn't mad. Mom should have used Glad Force Flex with an indestructible drawstring that grips the can and stays in place. Plus, it has destructible strength of Force Flex. That's all today for Glad TV. Don't get mad. Get
Glad.
Yeah.
Apparently they don't advertise that as well anymore. But
Or at all.
Cute commercial.
no, that's definitely commercial. You just saw it. I didn't make that. I didn't like spend last night to go get 2 kids, and I'm like, hey, record this commercial
I
so
wouldn't
that I
put it
can
past
make
you.
my
This kid had
students
more than
think
2 kids in the
that it's a real thing. No. Don't get glad, get mad. MAD stands for mean absolute deviation. Mean absolute deviation. And basically what that means is they're trying to get you, it's trying to give you an idea of how are the numbers distributed. Are they evenly distributed? Do you have a lot on the ends? Do you have most of them kind of like central, if like this is them, are they like centrally kind of grouped together? Are they closely grouped together? Or are they really, really are the numbers like way, way, way spread out across that? If they're way spread out, they will have a higher mean absolute deviation. If they're clumped together, they will have a lower mean absolute deviation. Mean, because it's near the, what does mean mean?
Middle.
What?
Middle.
Middle or average, which is not the same as median, obviously, but they're similar. And deviation mean like how do things deviate? How do they change? So how do we find the mean absolute deviation? I am glad you asked. So on bottom of page 205, it says, for example, you have let's say suppose you have this data set 1, 3, 7, 9. 1, 3, 7, 9. The mean of the data is 5, so add them all up. I mean, it's pretty easy to see. 9 plus 1 is 10, 3 plus 7 is 10. Hey, there's 20. 20 divided by 4 is going to be 5. So I find the mean is 5. That's the first thing. You already know how to do that. I know, don't make the class too much more complicated. The other thing that you're trying to do here is basically seeing how far away from the average is each of the numbers in here. Again, how far away from the average is each of these numbers in here. So if I'm trying to calculate the MAD, so mean, I just went and said, hey, what all these are. Now I want to know, I'm still going to divide it by 4 because that's how many numbers there are, but I want to know how far each of these numbers from 5. So 1 is how many digits from 5?
2.
Nope.
3 is how many digits from 5?
4. 1, 2, 3, 4, 5. It's
You
4
said
spots
how
away.
many digits is it from
How
3?
many digits is
3
it
from
away?
3 to 5?
I said 1 to 5.
No, you said 3 to 5.
He said 1 to 5.
Ha!
Madison?
I win.
Yeah, that's my name.
3 to 5 is how many digits away?
4.
That's 2. 7 is how many?
6.
And 9 is?
12.
Add them all up, divide by it. 4 plus 2 is 6. You got another 6. We got 12. 12 over 4 is 3. So the MAD is 3. So what that means is, on average, these are going to be, the average number that you find in here is 3 units away from the mean. Again, what that means is, on average, these numbers are about 3 digits away from the mean, not the average, not the middle, but the average itself, the mean itself. Lots of other stuff on the next page you don't really need to know. Top of page 207 says the table scores, so it shows the score of 10 people during a dartboard game. Frank, can you list those off for me?
Is this still 205? No.
207. Top of 207. 54.
40, 69, 49, 73, 42, 35, 60, 51, 57.
Okay, I got them all together. Does it matter if these numbers are in the correct order or not? Are you sure?
Yes, it matters.
Why does it matter?
I don't know. You said, "Are you sure to hurry?" So I was like,
No, she's right. It doesn't matter. Think about it. If you're trying to figure out, all you're figuring out is the average and how far numbers are away from the average. None of that do you need to know. Hey, this is what these numbers are. So, first step we have to do is figure out the
average.
average. Which, how many numbers are there?
1, 2, 3, 4, 5, 6, 10.
Okay, and this is where we use our calculators. So get your calculator out, put them together. 42, 35, 54. This is when you take your calculator out and start
I was
working.
doing it in my head. Do it.
Did you say you're doing it in your head?
Oops. All right, who's got it? What is it?
53.
It's
Yep.
53.
Okay, now, how far away are each of these from 53? 42?
Oh,
Oh, I forgot my addition signs in all of these, but you guys figured it out.
11.
Next, 35? You don't need a calculator for that.
Yes, I do.
No, you don't. This is what makes me want to take calculators away from people.
I'd be
18.
fine with that. I hate calculators so much.
Next,
Oh, which number?
54,
1,
60,
7,
40,
13,
51,
2.
69,
Oh, 14. I don't know.
16, dude.
I was just
53 to 69. 49,
4,
73,
10, 12, 20,
20, and 57.
4.
Alright, same thing.
Wait, what does MAD stand for?
Don't get mad, get glad.
No.
No, I'm just kidding. That's the catch line. Mean absolute deviation. So basically, how far do the numbers deviate from what the mean is?
Is all day 2 gonna be finding this?
Yep.
This is really frustrating. It's like
Frustrating?
It's
This
easy.
is easy.
No,
this
it's-
is like
it's easy, but it takes so many steps.
Don't get mad.
well, we'll see how much I actually do. What'd you get, Madison?
I got 9.6.
Yep, I got the same thing.
What?
What?
Okay, we're done. It doesn't take that many steps. The only thing you really have to write out is this.
I knew
You don't have to, they've got those big fancy charts in there. I'm not making a chart, I'm not making you do a chart.
Why'd you make a chart?
Why would you make a chart?
Why'd you write all those numbers down there?
These
No,
you
the
need to
one
write
above
down.
it,
The
the one
ones
above
above it so that we can reference it in real time,
Don't you have
what
a
the
book,
difference
Bill?
is. What?
Don't you have a book?
Yes, I have a book.
I have a book too. It says it right
Okay,
here.
well this is also for those who are watching at home or watching in the future who'd
Don't
like
they
to
have a
watch
book?
this. Yes, they will have a book. Alright, B, what does the mean absolute deviation, the MAD, tell you about the data? They're gonna ask you this question in the assignment. Your answer is the same every time. On average, the average number is 9.6 units away from the mean. That's it. The average number is 9.6 units from the mean. That's your answer every single time. Guided practice 3, guess what? It's the same thing. Yeah.
Do we have to write out that whole sentence or just write 900 for the answer?
I mean, you don't have to say it, right? You can put it in your own words, but whoever corrects it has to be able to read, hey, this person says on average, the average number is X units away from whatever the mean is. So you don't have to write out the whole sentence perfectly that way, but whoever corrects it has to
So
understand.
why
that's
do
what
we
you're
know?
reading.
Why do we need to know that on average, these numbers are 9.6
Well,
numbers away from the mean?
okay, let's compare it to what's something that you want to look at data for.
Crying babies.
What?
Crying babies.
Crying babies. Okay.
No, please
well,
don't do that. I
Let's
have a better
go.
one. I have a
No.
better
I
one.
got this. I
Please.
know data well enough. You're welcome.
No.
So let's go 2 different countries. Let's go the United States.
We're
and
doing a real one
Russia.
after this.
What?
Russia.
We're doing a
And
real one.
Soviet Russia.
That was about
Oh my goodness.
And he's not here to quote. So the United States. Let's just take 50 people. So you have a sample size of 50 people in both of them. And you look at both of them. You
Why
take
are
them from
50
random
people-
places.
Why are 50 people buying crying babies though?
Why are people
Why are people buying babies? Is the next better question.
Can't give you a good answer.
Praying for his future wife right now. Oh boy.
Quote, get your sticky notes out.
No, we are
All right,
not
so-
quoting the crying babies.
You're gonna have to have a bigger sample size. Usually in data, I mean, like you talk about the COVID vaccine, they had 16,000 people in it. They can't just like give the shot to get 10 people like what your assignments are, and be like, oh yeah, well 10 people, none of them got it, we're good. No, that's not a big enough sample size. In statistics, you gotta.
10,000.
What?
Think they do 10,000?
I just talked to Mrs. Brown about it last night. She was like, no, it's 16,000. I was like, oh, sorry. I was wrong.
No, the crying babies.
16,000. Wow. Either sounds like a lot. Sounds like it's a pretty legit study either way. But either way, you can figure out the average. You can find out the mean absolute deviation. What would that tell you? Let's say. Let's say that. What was the thing on like how long babies cry for?
How long?
How long babies cry for at night, or what? What was the?
This is just crying babies.
Okay. Well, we're gonna say.
How many babies?
Is this people buying crying
Ah,
babies?
this is hers.
How
We're
many
not
crying
buying.
babies do they buy?
No, we're not doing buying of babies.
Why not?
Okay, we're gonna say.
Adopting crying babies.
No,
We're not
we're done.
doing the
Nope.
buying of
We're gonna say minutes on average, minutes that the baby cried, I don't know, the first night home or whatever. And they've got like 120 minutes and we've got 118 minutes. I have no idea if that's way off one way or another. It's probably way higher because kids cry all the time. But if this is their average and they're mad, if your mad here is 20 and your mad here is 10, which country are you going to find the more consistently, like you can more consistently predict that the babies are going to cry for this amount of time?
U.S.
No,
Yes.
no.
Oh,
That you
yeah,
can
okay,
more
I get it.
consistently,
Because that would be closer. Those would be closer.
yeah, these ones would be
Okay,
closer than these
but-
ones. Boom, there you go, that's why you can use it.
No. I actually, that was a legitimate question because
I know, and
I
I
don't need to
legitimately
know.
answered it. You're
I
welcome.
don't need to know who has more crying babies, the U.S. or Russia. That's just like a normal word problem. Like, how is this actually gonna help me? Like, why am I learning this?
I said name something that you want to actually study.
I was gonna name something.
Okay, well you didn't do that yet.
Okay, how would it apply to stocks?
Stocks.
Stonks.
This is actually a really good question. So for stocks, let's say on average, let's compare 2 different stock prices. Like,
Crying babies.
let's say, oh, I got a good one actually. So Bitcoin and Tesla.
Okay.
So if you're looking at Bitcoin and Tesla, let's say that if you're looking at like, hey, the last, yeah, I've got his attention now. Let's say you're looking at the last like year and you're trying to predict like where do I invest my money in something. This is actually really, I don't invest in stocks myself, so I do invest in stocks. I just don't, like, I trust my retirement company to basically figure out how they're gonna adjust everything. I don't do it myself because I don't have that much headspace in my life. And sometimes, honestly, it makes me feel like I'm building my own kingdom here on earth as opposed to serving gods. But anyways, so let's say that the average for both of them, on average over the last 5 years, like that's actually a good sample here. Another one would be like Walmart versus Costco would be a really good one, because Walmart has like, it grows and grows and grows and grows, but Costco, like, consistently throughout the 2008 recession, I guarantee it was this exact same way last year. Costco, it doesn't grow as fast, but it's going to grow very consistent. So it's like, hey, which one do you want more? Which one's going to have the smaller mean absolute deviation? It's going to be Costco between the two of them. It's going to be more consistent. Between Tesla and Bitcoin, I don't know, let's say that it was like $40 and $80 or whatever. That's not it. It's not anywhere close to that actually. In actuality, the average here wouldn't make a big difference, because you can invest more money, you can buy more shares in one stock or another or whatever, so the averages don't actually make a big difference at all. But the mean absolute deviation, there'd probably be some more statistics built onto it, even because if these numbers are going back up, then that's going to make the mean absolute deviations different too. So there'd probably be another statistic thing on top of that that would analyze this for you. But if you're looking for what the safer option is, let's say that this is like 25 for Bitcoin and it's 10 for Tesla. Okay, well then you know Tesla is going to be the safer thing to invest in over a longer period of time, because Bitcoin jumps up and it jumps down. And if you've been paying attention to what the market looks like the last few months, you can see it's been I mean, it went up from, my buddy who's invested in it, he's got a third of a Bitcoin, and it in the last 4 months went from like $15,000 for a single coin up to $50,000 is about what it is right now for a single coin. Like, that's a lot of money, and that's like, he invested $1,000 in it to buy half of a coin, which he then sold part of it off later. He invested $1,000 to buy half a coin when it was $2,000 a share. So he's seen it go way up, but you also don't know what the predictability of the future of what Bitcoin's gonna look like. Tesla, well, one, you can, obviously, there's a lot of stuff that, like, Elon Musk, when he says things, the market goes up, the market goes down, just based off of his tweets. But we've also seen basically everything that he's touched has gone up and up and up and up over time. So as long as you're not saying, hey, I'm gonna pull out really soon, whatever it is, and you're okay with it over a long period of time, that's probably a safer thing to invest in. But if the rest of the other companies in the US decide, hey, we're gonna also invest in electric cars, maybe his value goes down at that point. And I'm not like an expert or whatever, but I can tell you this is probably the more stable one than what this one's been over the last few years. But other specific stocks, I don't know.